Okay, students. So let us continue. So now W equal to K by 1 minus gamma, like this we get. Now we have to do something. So this looks almost like, okay, the equation is over, it's a final equation. But we can do some variation. Let us see what is that. We know that P1 V1 gamma is equal to P2 V2 gamma, correct? Means we are applying the equation of the adiabatic process here is equal to constant K, am I right? Yes. That means K means can also be written as P1 V1 gamma or P2 V2 gamma because it is constant. So in the place of V2, or suppose you multiply, now what happens? K into V2, K into V1, like that's it. Actually no. So the K value I can use either this or this. Hope you can understand. Okay. So now what I do is, for the purpose of substitution, so that I can cancel here gamma values, that is why what I do is, either for V2 here I have to use this one, correct? So that it becomes gamma 1 minus gamma, their gamma cancels, remaining is P2 V2 only. Like that here, P1 V1, like that if I use means equation becomes W divided by 1 minus gamma into P1 V1 minus P2 V2. For that sake I am doing like that. Okay, let us see how to substitute that. Okay, slowly I will shift. Okay, fine. What is that? The equation can be written as W is equal to 1 by 1 minus gamma. After multiplying K value, after substituting, what you get is P2 V2 gamma. Already V2 1 minus gamma was there. Next minus P1 V1 gamma. Already V1 was there. 1 minus gamma. Hope it is clear. Hope you are able to understand this. Hope it is visible clearly. Okay, done. Next. You people know already that is A power M to A power N is equal to A power M plus N. Correct. So let us substitute that. When you do that, what you get is W is equal to 1 by 1 minus gamma. So what it becomes? It becomes P2 V2 minus P1 V1. That means final variation of pressure and volume minus initial variation of P1 V1. Like that we are getting right now. Correct? So go through it. Hope you are able to understand what the substitution I have done there. Okay. So now a slight variation we can do, I think. Means change of sign. If I want to write P1 V1 minus P2 V2, the sign convention will vary like this, no? W equal to, this becomes 1 by 1 minus gamma into P1 V1 minus P2 V2. Correct? So this will be the final equation of work done in what? Work done in case of adiabatic process. Okay? Next, we people already know that in case of, what is that? Generally speaking, for ideal gas equation, P1 V1 is equal to RT1 here. Why? Temperature. It is not absolute temperature. It means absolute scale of temperature it is. So P1 V1 is equal to RT1. And also we can write the ideal gas equation in second case, that is P2 V2 is equal to RT2. Correct? So now what we can write here in this place? R will be common for both. So also this equation can be written as what? So W is equal to R common I will take because in both it is present. That is why 1 minus gamma. Next P1 V1 R T1 R came out. That is why it is T1 minus T2. Okay. Hope you are able to see this clearly. Looks lengthy, kind of. What is that? Slightly complex kind. Here there is no need of by-hearting anything. Thing is, you have to follow the basics of gas laws, formulas you have to remember. So, carefully you have to substitute. Okay? Fine then. So, let us see now. So, let us get back to the derivation now. I will explain. So, look at there. So, derivation is, what is that? Derive the expression for work done in case of or in adiabatic process, students. So how to start initially? That is, you have to start with, consider 1 mole of ideal gas. Let P1, V1, T1 be the initial pressure, volume and temperature. Let the gas be subjected to expansion, or let the gas expand adiabatically so that the pressure, volume and temperature becomes P2, V2 and T2. Then according to the small amount of work done due to the variation of volume to the extent of dV, that is dW equal to P into dV, equation you have to write down. Then what else you have to write down? According to adiabatic process, that is PV gamma is equal to constant or PV gamma equal to K also we can write down. And of course the same similar steps we have to apply like how we have applied for the isothermal process. Okay. And then we have done what? Yes, this substitution we have done. So you can see there in the substitution what is there. That is, first you have to take with the total amount of work done case, and then you have to, yes, what is that? Work done, then limit you have to apply. After applying the limit, then of course there is fundamental formula which is actually required in this derivation. Hope you can see that. So what is the fundamental formula that is used here? That is, right now this has become V power minus gamma actually, right? So it looks like what? X power n dx. So what is x power n dx integration formula, fundamental formula? That is x power n plus 1 divided by n plus 1. So I have applied that one here, and some sign conventions we have changed here according to the rule only. We are not violating any rules here. So like that, change of sign, everything we have done. So hope the first step till the last equation P1 V1 gamma is equal to P2 V2 gamma is equal to K is clear for you, and there is no confusions in this. And similarly, after finishing that, next where you have to move is this one. And what is that? The next step, and the next step is what? Of course, that is W is equal to, that means from here we are continuing W equal to 1 by 1 minus gamma, and thereafter, just for the purpose of making the equation more simpler, that means without the requirement of the power, we can just modulate the equation. That is why in the place of K, what we have taken is K means according to the equation of gas laws, we know P1 V1 gamma, like that we have taken, so is equal to K. Like that, according to the requirement, we have written P2 V2, we have written along with V2. That is why P2 V2 has come first. So don't get confused why it is taken like that. It was actually purposefully it is being written like this. Because or else what we have to write here? Just K into like that. Now in the place of K like that we have written. And next W is equal to, yes, 1 by 1 minus gamma to P2 V2 minus P1 V1 we get. And after getting this, next step is what? 1 by 1 minus gamma. What I have done? That is P1 V1 we have done. That means gamma minus S. So 1 minus gamma is being taken there. So there is some small variation. So what is that variation? Because sign convention has changed, correct? Yes, sign convention has changed means when I have done P1 V1. So P1 V1, correct. That means this becomes what? Yes, gamma minus 1. Okay. Yeah. So here also, because sign convention is changed, that is why gamma minus 1. Okay. Hope it is clear. The equation where I have written 1 minus gamma that time, it was actually for P2 V2 minus P1 V1. So when it is shifted, so of course sign also will vary. That is why 1 minus gamma will become gamma minus 1. And then we have applied the basic equation of the which one? Yeah, ideal gas equation. In terms of temperature also we have written here. So W is equal to R by gamma minus 1 T1 minus T2. Okay. Fine then. Hope there is no confusion in this. Hope very clearly you understood about this easy derivation, we can say. It's not very difficult or complicated kind of derivation, students. So write neatly in your notes. Okay, very important derivation it is. Yes. Fine then. Hope you have noted all the required steps, interpretation, everything is written. So next let us go for the upcoming topic, and the topic is something about engine. Okay, fine. So regarding the derivation, hope everything is clear without any confusions here. Yeah. Fine. So make a note here. Hope you noticed 1 minus gamma was there when P2 minus V2 minus P2 V2 minus P1 V1. Then it is being interchanged. So sign convention has interchanged. That is why here also sign convention have changed. So this becomes gamma minus 1, students. So here also it becomes similar. Okay, that means that side. Hope you are able to see that. Okay. Yes. So I repeat one more time. Derivation till here it is according to the substitution only which is done according to the rule of integration, everything limits, and then it is being continued like 1 minus gamma P2 V2. We have interchanged the position of this, in the sense sign change has taken place. So P1 V1 comes first. So meanwhile here also sign changes. That is why gamma minus 1 I have written later on. So hope you have noticed this. Yeah. Fine then. Let us go for the next topic, that is heat engine. Okay. Next topic is heat engine, and the last topic also. Means one of the type of heat engine we are going to learn, that is Carnot's engine, and along with that the reverse heat engine, that means refrigeration, that concept is there, right? That also we are going to learn. So what is this heat engine? Heat engine means a device which converts heat energy continuously into mechanical work. Correct. That means, of course, automobile engine, scooter engine, bike engine, whatever engines, or pump also, diesel or whatever pumps, generators, what they will do, of course, the fossil fuel will be burnt inside. Example, diesel, petrol, or whatever. Usually gasoline we say, no, that one. Because of burning of that, what will be produced? There will be, yes, heat, enormous amount of heat energy will be produced. That heat energy will make expansion inside. Because of that, mechanical work will be done. And heat engine means it is actually a device which continuously converts heat energy into useful mechanical energy. Okay, that means what is required now? It should be provided with heat energy. Okay, then only it will do work. Without providing anything, it won't do any work. Okay, that is what heat engine means. Definition, better write down neatly. Okay, that is engine. Heat engine is a device which converts heat energy continuously into mechanical energy. Okay. Next, let us see. That is principle of heat engine. Principle of heat engine. So what is this principle of heat engine? Why it is important? That means heat engine means you already know now. What is that? A device which continuously converts heat energy into mechanical energy. So what is the principle of it? Engine means, of course, various parts will be there, correct? Various parts of the engine will be there. According to the principle of heat engine, listen carefully, the various parts of the heat engine, if it is maintained at different temperatures, it tries to change itself to become thermal equilibrium. Okay, if the various parts of the heat engine is in different temperatures, it tries to become thermal equilibrium. So while becoming that, what happens? Mechanical work will be done. Okay, that is what the principle of what? Heat engine. Hope it is clear. So principle of heat engine means what? So fact that system whose different parts are at different temperature tends to change towards the state of thermal equilibrium. It is used as the principle of heat engine. Okay, students. Next, that is about the introduction of heat engine. Right now, usually, you people, many of you might be knowing how to ride a scooter. That means petrol, gearless, gear with the gear bike also. Fine. Now, heat should be provided to the engine. It will do work, mechanical work, all those things. It is clear for you. And next, suppose you are having a engine or a bike or car, whatever. When we say it is more efficient, when we say more efficient, because it gives more efficiency, that means more mechanical work has to be done compared to how much heat it has absorbed. We compare with the output with respect to input. If input is more, output is less means, then whether it is efficient? No. Yes or no? That means we will put 1 liter petrol and the bike will travel for only 10 kilometers. One more bike travels for 100 kilometers or 60 kilometers. Which one is more efficient with the mileage point of view? 60 kilometer or 100 kilometer. That means when you design an engine, when there is a heat engine is designed, the efficiency is actually matters there. If it is more efficient, it makes or it doesn't consume more amount of heat energy. That is what the concept. So efficiency. Efficiency of heat engine. Efficiency of heat engine. So what is efficiency of heat engine? That is ratio of net work done by heat absorbed. That means there is a symbol actually. Okay, symbol means eta symbol already you know. That is what we are going to use for efficiency also. Okay, that is net work done divided by heat absorbed. What is net work done? Net work done means how much energy is consumed to do external mechanical work. So net work done we can take W is equal to heat supplied minus utilized. Heat absorbed. Heat absorbed means what? Heat absorbed. Okay, I will write down here. Net work done. Then heat absorbed means initially how much it is supplied. It is also Q1. So, therefore the equation of efficiency can be written as W is equal to Q1 minus Q2 divided by Q1. Correct? So, work done is Q1 minus Q2. So, there is some common factors in the numerator denominator here. So, this becomes what? So, this becomes W is equal to Q1 divided by Q1 minus Q2 divided by Q1. Correct? So, this is common actually. Common in the sense, don't want to write like this. Just let me write directly. What is that? Q1 minus Q2 by Q1. So, that is why this is 1 minus Q2 divided by Q1. So, what is this actually? Efficiency. Here I have written what? Work done. Correct? Because I have taken the ratio here. Ratio of. So, that means this is not work done. This is efficiency. What is just work done? Q1 minus Q1. Okay, this is. Okay, I will write here. Okay. Yes. So, what is heat engine? The device which converts heat energy into mechanical work continuously. Principle is, if the different parts of the heat engine is maintained at different temperatures, it tries to change itself into mechanical equilibrium. That is the principle. Last is the efficiency. Regarding efficiency means what? It is the total amount of net work done by heat absorbed. So what is net work done? That is Q1 minus Q2. Okay. Next, difference in between heat supplied and utilized. Next is, what is that? Heat absorbed. Of course, it is Q1 amount of heat absorbed by the system. So, eta is equal to efficiency is Q1 minus Q2 divided by Q1. So, finally, we can write the equation for this one. Efficiency is eta is equal to 1 minus Q2 by Q1. For which engine? For heat engine. Okay? Fine. Next, you people know that more is the heat energy required or supplied, more is the temperature. Less is the heat energy, less temperature. So, heat and temperature has got a close, relation? That is why in terms of temperature, if you write means, eta is also possible to write like T2 by T1. So, this is also one of the formula in terms of, what is that? Temperature. Okay, regarding heat engine efficiency, students. Hope you understood the definition and all. Yes. So take down neatly. So heat engine definition you write neatly. Principle of heat engine also write the principle as I explained. Efficiency of heat engine also. Okay. So everything should be defined. Neat notes you have to maintain, because though it is video class, our approach is same for you people. Okay. How we explain in classes, the same methodology will be used here also. So listen to the video class properly. Pay attention. You will understand. Okay. So this is about the heat engine and along with that efficiency formula. So let me erase this then. Fine then. So now the last two topics are remaining. And what is that last two topics? That is one of the important 5 marks topic it is. Actually it's regarding explaining of one particular engine called Carnot's engine. And at the end we have got regarding the refrigeration, it is there. Refrigerator, no? You know, right? Refrigerator. That principle we are going to learn. So you'll come to know, yes, how your refrigerator at home works. Okay. Hope what and all. So far we have discussed like isothermal process work done equation, adiabatic process equation for work done, and regarding the introduction of heat engine principle and efficiency concept. So all these things are clear, I think. Yes. Let us go for next. Carnot engine. Okay. Topic is, it is not car engine, Carnot engine. Scientist's name. He explained about an engine, variation of pressure and volume. That is PV diagram it is called. That means pressure versus volume. That is PV diagram. Okay, like that. So Carnot engine. Write down neatly. Very, very important. For how many marks? 5 marks. Usually in all the examination, almost all the examination, this question is being asked. Explain about the different parts of Carnot engine and write the expression for efficiency, like that. Or explain PV diagram using the concept of Carnot's engine for 5 marks. So when there is a word explain comes means you have to explain each and everything. Don't do like the previous examination where I have asked you people to explain about what. State and explain Newton's law of cooling. Only definition you have written. What is that? Explain in the sense what? There is actually derivation. Steps has to be explained. No. Yes. Same thing here also. So Carnot engine, write down side heading 5 marks and mark it important. Very, very important. Yes. So what is speciality here? Let us see. See, this is actually a hypothetical engine. What is that hypothetical engine? Means normal engine means what? Of course, in normal engine, friction is there, lubricant has to be used, everything, coolant has to be used. So many problems are there. Because of that, along with that, vibrations also will be there. Correct? Noise also will be there. Yes. So all these things are actually the, yes, practical difficulties. But this Carnot engine actually, it's an explanation. It's an ideal heat engine. What is this? It's an ideal heat engine. So ideal heat engine which is free from yes, what and all? Friction and yes, imperfection also you can say. Okay, that means noise, all the vibrations, etc. Friction and imperfection, free from friction and imperfection. Imperfection means what is that? Of course, that is heating, heat loss, all those things are there. No, that one. Imperfection of actual engine we can write down. Yes, so this is actually the definition of Carnot engine, students. Okay, take down the definition. Next, let us discuss about the different parts. What is that? Different parts of Carnot engine. What is that? Different parts of Carnot engine. Let us see. So here different parts are there that has to be studied first, which is very, very important. Then explanation part we can go for. Okay. Yeah. What is that? Different parts of Carnot engine. Let us see. Okay. Now let us see what are the different parts of Carnot engine. Okay. So there are different parts here. Let us see what and all. First one is, that is working substance. Already we know about it. We used to take it as an example for understanding thermodynamic process, that is container, correct? Yes. So which has got a frictionless piston and perfectly non-conducting. Okay, this container, or this is called working substance. What is this called? Working is one of the first part, okay, or important part of Carnot engine. Working substance. So what is working substance? It is actually a perfectly conducting base and perfectly non-conducting wall container along fitted with frictionless perfectly non-conducting piston. Next, to make it work, no, we require heat energy, no. So as a heat energy source or a source, there is something like this. That means everything is explained in block diagram only. Okay, so this is called source, which is perfectly conducting at the top and insulated at the all other corners or walls. This is called source, which is maintained at T1 Kelvin. Which is maintained at which Kelvin? T1 Kelvin. So now source means, of course, source from where energy is supplied. Alva. So energy is supplied here, heat energy. So that will be absorbed by whom? This particular container, that is working substance. Because of absorption, of course, the gas will increase, work will be done, all those things are there. Pressure, volume variation takes place. Now if you want to cool down the system, that means in car engine and all, of course, coolant will be there or water will be used in olden days, correct? Water has got highest specific heat, that is why it is used as a cooling agent. Now, if you want to cool the system, we require something, no? That is why, like how the source is there, like that one more thing is there, that is called sink. It is not the sink or the basin which you people use at home. It sounds similar, but this sink is something different. What is this sink is? Heat sink. That means it will absorb the heat maintained at low temperature, that is T2 Kelvin. Heat sink. Okay, done. So only 3 parts in the Carnot engine? No, last one more part is there. That is something to make the working substance to keep on it, and there shouldn't be any thermal exchange or heat exchange. That is why some isolated system is required. That is why non-conducting stand, last one. The perfectly that means all the means in diagram we show like this. Non-conducting stand. What is this? Non-conducting stand. Yes. So that is what? There are 4 parts. In which one? In the Carnot engine, students. So in these 4 parts, first one is working substance. So what is working substance? Working substance means you have to write down that. What is that? Means this question can also be asked like this. What is Carnot engine? Explain its different parts and arrive at the equation for efficiency. That I am going to do it. Okay, next after this. But explain about the parts means after drawing the parts you have to explain it. What is that? Don't leave just with okay, only diagram. Not like that. So first one, that is working substance. So what is working substance? So working substance means it is actually a perfectly conducting base, perfectly non-conducting wall, fitted with perfectly non-conducting frictionless piston. Okay, that is what working substance is. So take down working substance. It's a cylinder. Okay, shape is like cylinder, no? It's a cylinder with perfectly conducting base, perfectly non-conducting wall, fitted with non-conducting frictionless, what is that? Piston containing an ideal gas as a working substance. So why ideal gas? Because it is an ideal heat engine. No, that is why ideal gas is used inside this. Okay? Fine. Working substance. Explanation is over. And the next one is source, which is at T1 Kelvin. So what is source? Source means it is actually a part of Carnot engine where it is maintained at very high temperature, very high constant temperature also we can, okay, just very high temperature. So T1 Kelvin it is kept. So define So write down source means what is that? Source is a source, that is it's a hot body of infinite thermal capacity you have to write down. Okay, source is a hot body, correct, having infinite heat capacity. Infinite heat capacity maintained at which temperature? A constant high temperature. Yeah. So that is actually the second part of Carnot engine. What is the next one? Next one is sink. What is sink? Sink, already I told you people, to absorb heat energy it is there. That means to cool down. That means it should be what? A cold body, correct? Yes. It should be a cold body. Next, what else should be there? Infinite thermal capacity. Here also it should be there, correct? Yes. Here also infinite thermal capacity. Whatever heat is given to it, it has to absorb. Here it has to provide, that is it. Infinite heat capacity is there. Should have infinite heat capacity. And it should be maintained at, here maintained at high temperature. No, here what about this one? Maintained at constant low temperature. Okay, so working substance, that means a cylinder containing all those things with, what is that? Ideal gas is the working substance. Substance is ideal gas there, but it is actually inside the cylinder, all those things. What is source? Thing which provides heat energy for the working of the system. That is source, T1 Kelvin. Okay, here which is maintained at which, that is T2 Kelvin. Okay, you can write down there. And it's a hot body with infinite heat capacity, and then maintained at high temperature, constant high temperature. Then sink, what is that? Cold body with infinite heat capacity, maintained at constant low temperature. And then what else is there? That is last one, non-conducting stand, correct? There at the corner I will write, hope that is visible for you people. Perfectly non-conducting stand. So what is perfectly non-conducting stand? It is a perfectly non-conducting stand which doesn't allow any absorption of heat by the system. That means it doesn't absorb anything from the system. If system is kept on this one, no exchange of heat. Something like thermal insulation. Okay, so no explanation required for non-conducting stand. You can just, if you want, you can write. It is a non-conducting stand means having the insulation for heat exchange. So when system is kept on, or when the cylinder is kept on non-conducting stand, there is no absorption or emission of heat energy. Okay, this much you have to write. For which one? For the explanation.